Okay, I reduced the bit rate. Let's see if it's gonna keep uh, struggling the stream. Where I see that start? Yes, I see here. I have an inspector here and I can see the dropped frames. So let's see if it's okay now. So let's back here. We are actually trying to run that for the string function. So let's do that. I will open the Spago reply terminal so we can like try this code here, and I will copy and paste all those code here. Okay, let's declare this function here. Type class declared. Let's declare this instance here. Instance declare. Let's declare this other instance here. Oops. Copy, paste, enter. Okay. Now let's import this picture here. Oops. And let's declare this function here. Okay. No data construct, nothing. I need to import the maybe here need to be imported with this expression operator. That means import the type and all those constructors, all its constructors, right? So I'm not importing only maybe, but just and nothing. And so I can again try that code here. Yeah, work it. Now let's try to use that fold string function for a given type, right? And the thing I was looking for is to use that with the first example here. Let's try the array example, right? So let's try to use that with array to see what's happened. So, for example, if I try to do fold string with a given function, which takes the array element called e, and let's say it's int for now, right? So let's try to, don't know how do I append that with something which is appendable. I can have like try to do I was thinking to turn that thing appendable to make that thing string. But let's say it's gonna be another array, right? So the return thing is gonna be array with the a thing. So we obey to the requirement of having a return monoid, because we can see that array we can see that array has actually a instance, right, for monoid. So in this case, let's try with that to see what happened. And the list here is a list of items that gonna be transversed by this function here, right? And this list must be let's see here, yeah, this thing here is passed through the uncons function of array, and there is no such law asking us to use like a monoid in this list here, right? Look at the L thing here. There's nothing asking us to use array, something like that. But how is this possible? Because uncons must receive array, right? Yes, because I'm actually implementing array uncons, I can see that uncons function here, because you know, if I am receiving something here in an instance, I am actually constrained that even that my class is not requiring that, but my instance implementation is requiring that. So I must obey to the uncons function here, and that uncons function is asking us to pass array with something, right? So let's pass a list array actually with values 1, 2 and 3. Okay, let's see what's happened. And yeah, we can now enter this function because there is no more parameters here, right? So let's try that. Okay, we have a problem here, is that we have no show instance, type class instance for T2 while applying a function. I know that it's happened because the return value here, when I do enter here in something like, hey, look at this, when I place something like this in terminal, I'm count that this enter is gonna be showable. Like I can show something, I can show 1 and it's gonna return string, right? It's the same thing as enter something here in terminal. And when I do something like this, let's see what's happened, right? It's array. It showed that array. But if I do something like, hey, it's another thing inside array, not just a int string or something like that. Let's try that to see what's happened. It works, right? But if I do something like, hey, the thing is, the return thing from the fold string here, the monoid, right, is not showable to that show function. no type class instance was found for show t2, except that while trying to, let's see here, the instance head, I see, the instance head contains unknown type variables because we are returning actually a monoid, and but let's see here, the instance head contains unknown type variables. Consider adding a type annotation while solving type class constraint show array something. My guess is the compiler don't know who is this A thing here. It cannot infer that. I have seen that before. This A thing here, we are not actually say, hey, it's a integer. I'm not saying that in the instance, right? Because I want this function here on const to work with an A value, not only int values. And because I'm not saying that, the compiler don't know which values are inside, right? The compiler don't know how to resolve that. So the thing that I can do is specify that instance, or I can like type hint the compiler to know which value is that at runtime, right? And let's try to do that. I will say that this thing here is of int. Let's try that. I don't know if it's gonna work. Maybe should I do that in a thing here? Let's see that. No type class instance was found for string array int while applying a function for the string of type. Let's do something. So let's see if it changed something. I will like call this callback. I need to paste that. So let's say this thing here is let's call this, don't know, fn for now, and I will say this fn is a function that receives int, which is the int number, and returns a monoid, right? Yes, it returns a monoid. Yeah, in this case I need to say, hey, I want to specify here, so array int, and we know that array is monoid, so it's okay, it's gonna pass. So let's try to implement that. I will receive that like element, right? And I must return array with that element, and let's see what's gonna happen. What I did wrong. Oh. Yeah, this is not like a function that calls something like that. I no, cannot use that fin here, so let's do this way too. So I'll create this function here. Yeah, I need to paste that. So I'll create this function here called fin for now, just to, as an example, and let's see what's happened. Here's the fin function, and let's see that. Yes, can check that fin function here. It takes an int and return array int, and let's try to call float string with that fn function. No type class instance was found for string array int and int. I need to specify that to use that. Cannot I use a general type like this? I was thinking like, okay, A is generic, so don't matter what A is, just pass that array cons, but I'm seeing that the compiler is requiring us to like have an instance for that value. Okay, let's try to do that, so to see what happened. Probably gonna solve, but I don't know why it is required, right? I was willing to work in this general form here. Let's see. So I will add an instance. I'll copy that here and change the a value to int. And let's reuse the same thing, right? Okay, now we have an instance for array int, and let's try to run that again. Yeah, it worked. And to recap, our fn function is just return the element itself inside of a monoid, right? Which is this array here. And we can see that I was thinking that element's gonna have like the resulting array is gonna have something like this thing here, like something like that, but it didn't happen. Let's see why. The monoid thing that's being returned here is being used in here. So we take that head and append them together with its tail. When I do something like that in a int value, I see that because let's see here, the m thing here, it's being returned here, because the unconst function return a maybe thing, and I see that we are actually passing that head thing to f function, which returns another monoid, right? Inside, like in this case, array, right? So this function here returns array, which is append with the rest of the array. So we are append together arrays here, not just values. So that final call append the values which are inside of those things here together, and we can see that the result of appending something is a monoid, which in this case is the array, right? So let's see the append operation for array to understand what's happening. So it's probably same group class, right? And because we have append here for a given type, in this case array, it must return array. So when you append two arrays together, it returns a third array. It's not like taking the values and adding in a new array, inserting a new array. No, it's taking the values of each array and build a new array with the both values of both arrays, the values of both arrays. So it's like a flattening operation. You take the values, flatten them together and make a new array. So that's why we are not return something like this, and we are actually return this. And what if you build a new function and that function does something different? Like, let's try to understand that. If I do something like let's say I have this fn line function, and let's see here, instead of it's the same signature, I need to pass that. So it's gonna be the same signature, but the implementation is gonna be different. I want to play a little here to see what's happened. Let's say that element, instead of just return the element, I will return element times 4. And we can do that operation because we know that int has an instance for semi-ring type class. That's something magic. That's something logical that I love so much in this language. Those math operations are actually type class instance. So we know that the move function, if I'm not wrong, yes, it's in semi-ring package, right? And we can see that the move function is an instance for move member, which is a member of semi-ring type class. So just a moment here, guys. Okay, it's okay. It seems to be everything great here. Yeah, it's my preview here from the Twitch dashboard is freezing a little, but it's just a playback. the the tweet, the stream seems to be okay. Let's just let me look here to the. Is there VFQ right? Yeah, Bluetooth. I guess that my Bluetooth hardware is making my Wi-Fi connection oscillate because my notebook have this, and if my Bluetooth is powered, my Wi-Fi just dies. So, but I'm using Arch Linux without any Bluetooth thing. Bluetooth applet here without any of that, and I don't know if it's, you know, installed something. It's Blue Main, right? Not have something like that. Could my Bluetooth be powered on, and trying to okay, I will try to block. Let's see if it changes something. Block 1. And block 2. Okay, I had tried to software block my Bluetooth to see if it improves a little my stream. Let's see. So back here to our exercise, we are actually trying to write this function here, and that multiplies this element by 4. It's just take an int value and return array of that. And this function here, fold string, is gonna run this fn line function over those values here. And if it's working, if I'm not wrong, it's gonna change the 4 value here, the 1 value here to 4, the 3 to 8, and the 3 to 12. 11, 12, right? Yes. So let's try that. Alright, it's working. So it's working as we are imagining. Okay, so this finished the multi-parameter type class subjector here, and we have this function dependence here. Let's try to recap that. I have seen that before in last stream, don't remember when, but let's remember that. Multi-parameter type class can be very useful, but can easily lead to confused types and even issues with type inference. I remember that. That is a kind of thing like when you have something which is not obvious, like we have see that here, right? We have this array a thing here, and because there is no such instance for that a thing here, the compiler don't know how to handle that situation, how to infer that type, right? And when this happens, I can add some functional dependence to say, hey, you can figure out that type, and that's exactly the thing is happening here with the string and element. You see that here we are actually hinting the compiler that you can derive the element type from the string type. Here, string element is called function dependence. A function dependence asserts a functional relationship between the type arguments of a multi-parameter type class. This functional dependence tells the compiler that is a function from string types to unique element types. So if the compiler knows the string type, then it can commit to the element type. So it's like wait to an instance definition where element type comes from that instance definition, something like that. This hint is enough for the compiler to infer the correct type for our generic tail function above. Generic tail, like this one here, right? Yeah. Yeah, because when we try that, yes, it triggers this error here. Functional dependence can be quite useful when you use multi-parameter type class to design certain APIs. Alright, I remember that, so I'm gonna go forward that. And finally we have nullary type class. We can even define type class with 0 type arguments. I have seen that. Those correspond to compile time or sections about our functions, allowing us to track global properties of our code and type system. An important example is the partial class, which we saw earlier when discussing partial functions. Take our example, the functions head and tail defined in data array partial that allow us to take the head and the tail of an array without wrapping in maybe, so they can fail if the array is empty. So here we have the head and tail function. We have seen that before, right? Which takes a value from that array and a tail that returns a new array with the tail of that given array. And we can see that constraint about having an instance for partial type class. Note that there is no instance defined for the partial type class. Yes, actually that's true. Doing so would defeat its proposed attempt to use head function directly will result in a type error. So okay, if I try to do that, let's see here, head 1, 2, it must return 1, right? But it will throw. I need to import that. Probably data array, right? Let's try. Head, tail. Yes, so let's try to call head. It worked. Probably something that has changed, don't know, in the terminal. And if you try, okay, because maybe because of its only two values, let's see that. No. And let's try with tail to see what happened. Okay. So my guess is the show is a partial function right now. So this is our inside the show function. Let's see that. Type show, right? Not actually. Don't know. Instead, we can replace the partial constraint for any function making use of partial function. I don't know why head is a partial function actually. I see that because head returns a maybe, right? And we need to pattern match that result to handle nothing situations. So a situation where just call head without giving any values. What happened in this case, right? So I must handle that situation, right? And in my guess, probably this head function is not the function we are actually. Yeah, it's that function. It returns maybe. So the only explanation for that is that the function that's which is being called when I just input some values here. Let's try to just one to see what's happened. Just one. And if I do nothing. Alright, oh yeah. So it don't accept nothing, it accept just one. So we have a problem here. But let's keep forward. I don't want to care about that now. The thing is, the partial constraint is required for any function that can have when we use something, when we are using like a type. Let's see. Instead, we can republish the partial constraint for any functions, making use of partial functions. Here we have a partial type class, instance constraint. And in this case here we are taking the second element of a given array, and we know that our array can have like one element or non-elements, right? And we know that all the PureScript functions by default must be total functions. It means that it must handle all the possible construction of a given type, right? So this means that if we had like here is returning maybe a maybe type which has nothing, just construct, I must add alternative to handle nothing, right? But I can skip that with the partial constraint, right? We have seen the unsafe partial function, which allows us to treat a partial function as a regular function safely. It allows us to treat a partial function as a regular function safely. This function is defined in the partial safe module. Unsafe partial. For our A, we have that's interesting. Never had that before. We have here a thing, right? Which is constrained about. We are actually constrained about having. I don't know why this point is here. Cannot just. Is the A thing which is constrained about having partial, right? Is not the no. Is not the, because here like we are constrained of having partial instance for. I see that we, how that's possible. Okay, that instance here, because we know we can use it's a honorary type class, right? It not demands an instance, we just declare the class. And this function implementation is constrained about, it's not actually constrained, it's telling to the compiler that we are obeying to the partial law without even instancing something. So we are just saying I obey to that law. And unsafe partial is doing the same thing, but for a given A. And this A is a function, right? Yes, it's a function. but we are not constrained about that. It can be anything, but that anything is constrained, must be constrained about Portio, right? So this thing here, we know that this thing here must be a constraint about Portio, and is going to return a non-Portio thing, right? Note that Portio constraint appears inside, yes, the port is on the left of the function arrow, but not in the outer for all. This is unsafe Portio. This means that, because if it was outside of the parentheses, for example, I would say that unsafe Portio is Portio, but it's not the case. The case is A is Portio, right? That is, unsafe Portio is a function from Portio values to regular values. So like here we have unsafe part from head, passing head function, it's a Portio function. Let's see here. I look for the type of head function. So yeah, it's not a Portio function. Array head is not a Portio function. That's interesting, right? Probably because we are using wrong function. Let's see monoid here. Yeah, monoid don't have that. Let's see here, head function. So my guess it's not this function here. It's like a function that uses this thing here, right? Which is Portio. So I see that, yeah. So it's not that important function. It's something like I am right, my function, and my function had this behavior, right? Not the our data array function, nothing like that. Of course, he is using with arrays. Note that Portio constraint appears inside. See that? Okay. So when I call unsafe Portio with a given function, what's happening here? Because head receives array, right? My guess is the only way to solve this thing here is for head being passed to unsafe Portio and being applied to this array here. Same thing for second element here, which is Portio, right? That is, unsafe Portio is a function from Portio values to regular values. Let's write something here just to see what happened, right? I'm gonna say second element to try that one. That one is possible. First, let's try to paste this code here. Oops, but I will change that. Yeah, so let's close that. I'll change that without Portio to see what happened first. I want to try that. So I'm expecting that to throw because I'm not actually handling all those situations here in the second implementation. It's missing the return for nothing here. We are handled it just let's see what happens if I do that. Okay, it's not a total function. Or even not that. I of course I'm using the total wrong function here. It's not the head and tail function. Let's see here. Could not match type maybe. With type array. Yeah, it makes sense. I cannot match that. So that maybe thing is messing with me. Would that be one of those models here? Let's see. Not this one. Let's see that portal here. Oh, I see that. So we have a portal function. So let's to clear that terminal here and start again. And this time I will import that head from that package instead of just data array, because this is the same thing that you have seen so far. So I'll import that part. Okay, now I have all those functions, and I can like call this thing here. Let's copy and paste that. I will try that example first to see what happened. Let's see. Now it must trigger, right? Yeah. No type class instance was found for portal. So look at as it's different. We have data array. Look at this head function. It's a portal function. So we constrain about having about being to this portal allow. Right, and let's see this portal type class here. The portal type class is used to indicate that a function is portal that is not defined for our inputs. In practice, attempting to use a portal function with a bad input will easily cause an error to be true. Though it's not safe to assume that this will happen in all cases. So just to this is a standard class. It don't have anything inside of that. You don't even have a code to that, right? So it's like you say, hey, I obey to this law, and it's a signaling of that function, right? Something like that. And having something like that allow us to not trigger. The compiler is gonna check that function has this law, has this constraint, right? And will not throw if the call is missing, if the function call is not handling all the possible values for a given type, right? So this is the head function from this data array portal, right? That it has this constraint, and we have this data array which has the same head, but in this case is not, there is no such portal constraint here, which means that he's not gonna throw if I just call that in terminal, because show can handle maybe values. right? Because when I put something here in terminal, internally the terminal is calling show function, and show function has some internal behavior. I need to import prelude to do that. What's, what's I'm doing here? It's not. It's not that. What? Okay. It's the JavaScript way to write code that's messing with me. So I've imported Prelude that has the show function, right? So we cannot see here because it's inside this show type class here, but there is internal behavior to allow to show to handle maybe values, right? And because of that, calling ahead from this package is not gonna throw anything terminal, but calling ahead from partial model is gonna throw, because we don't this head has this specific law here, right? That that like implements that constraint about having the calling guy must handle all those situations, because by default all the functions of PureScript must be total functions. So back again to our reading here, we can see that need to paste that. I'm declaring this function here, right, which is also a partial function, so I can handle because it's a partial, right? I don't need to handle all possible values from head, and because it's a partial function, it's gonna allow to do that. Okay, but when I call that second element function with anything like this array here, for example, it's gonna throw because I'm not handle all the possible scenarios yet. And when I say that, it's like to remember, array can have an element. Of course, the resulting of this head function can have a element, right? But because head returns the first element of the array. But what happens if array is empty, right? So we don't handle this scenario with the function signature anywhere, and that's why the compiler is throwing. But if I call this unsafe partial function here, I'm like allowing to the compiler do that with that function. And let's look at the unsafe partial function signature. No value safe. From where this come from? Let's look at that. Let's look for that in Pursuit. It's not in Prelude because I have imported Prelude. Yeah, it's inside of a special package. So I need to import that from partial, right? Let's try that. Import partial, unsafe partial. Okay, it's even worse than that. I don't have even the package in this in this project. So I need to install this package to use that. Let's install this one. I guess it's here. Yes, dependency. So I will copy that and paste here. We have Portio here. If I have Portio here and it's not running, okay, probably because this reply don't run this dependency. How do I do that? Let's see here in the reply command. Yes, we have this dependency that allow us to like add this package as dependency, probably, right? And I need to just the Portio because I have set that here. I don't need to use PureScript dash Portio. But what's happened? But it's using okay, but not dependencies, right? It's using paths. Okay. Okay, I have used that wrong. The how spell? Here, dependings, right? So okay, let's try to import that again. New save Portio and come on, was that wrong? Let's just import Portio to see. Okay. Let's see here. Type unsave Portio. Oh, why? I mean, it's writing this wrong. Hmm. What's happening here? I can like see what's inside that Portio thing. Let's try to do that. No. Show all imported more. Let's try that. Show import. No. Let's try the loaded. Okay, this is better. Seems to be missing something here. I'm just trying to use that in save Portio function. And there is a clear comment. So it's not here. Set the reply print function. You see that print that as I have told before? I can like see what's currently. We use this PSCI support eval function. Let's see what's that. I probably need to import that. I don't want to do that. And if I do that, no, okay, no problem. The thing is, I want to use unsafe partial function, and I cannot do that. And I really want to know why. Let's try to do this way. It's not that, right? Because let's see here. Show import. Don't import. I need to import partial, right? Now let's see. Okay. And so we have a type in unsafe partial, right? We don't have. Maybe in partial.unsafe. I see that. It was the documentation trolling me. So yeah, we have this function here. Let's see where we are. Yeah, we want to try that with that function here. Let's try that again. It's gonna throw because I don't have imported that. I must import that data array partial, right? Now I have access to head and tail functions, and now I can copy and paste that. Okay. Again, if I copy and paste that without handling although the partial function, because the default behavior of the compiler is to throw, it's gonna throw. Okay, missing. We have actually a problem here about the partial thing. Let's import prelude to fix that, because partial is inside that package. And let's try again. Okay, this is fine. This is the error we are expecting actually, because we have, yes, this is the error we are expecting, right? Yeah. So this is a requirement to use unsafe. We need to handle all possible scenarios to call a partial function, or we must call unsafe partial with that function. First, I'm gonna try that to see what happens. Let's see here. So for example, here we have a second element, and we want to return that 2 value here, right? Let's see what happened. Okay, it returns 2, but if I have one single element, what's gonna happen? I see that. Interesting. So what is happening is that the code is failing in the runtime and not in the compile time, because every safety constraints are being actively ignored by us. Use that unsafe call, right? That's what's happening. So it's nice to have a way to do that, right? To handle specific case where runtime safety is not possible. So we can like ignore those kind of problems and let that thing happen in the runtime. It's not very beauty, but it's useful. Sometimes we just need to do that. The world is not perfect, right? Sometimes you just need to, okay, let that crash at one time. So unsafe port allows us to do that. Interesting. But if I need to actually handle that, how do I handle something like that? Let's see here. We know that second element. Let's see the type. We know that the type signature. Let's see here. Yeah, we know that type signature. And let's say we have a function called safe fn, right? It's gonna handle that situation where you have empty value. How do I do that? Let's see. I can have something like, hey, this is the safe function, and it has it handles all those situations, and it just returns it will return like a maybe thing, right? Because we know that maybe, but let's say it's gonna return array, right? Array of things, and we're gonna say, hey, if it's not nothing has been found, I'll just return our empty array, right? If the element is not found was not found actually on the array. How do I do that? Let's see. I can say, hey, just try to do second element. I can use like case second element of. Yeah, I want to do that again. I closed the terminal. I need to import everything again. No problem. Let's do that. First import balloon. Next import array partition, and let's import what more? Partition safe. And now I need to copy and paste that code here. Okay, and now I need to paste the safe function. Where is it? Here, safe. But I will change something. I want to pass array here, right? And return another array. Actually, I need to return int value here, which is the element, right? Or just wait, a. Yeah, I need to return the a thing. But okay, how do I handle the situation where we don't have a value at all? In this case, we're gonna have a problem because yeah, I need to specify that to something tangible. Like I need to specify that for int values, right? To handle all those situations. because I can say, hey, if anything was found, I can return something like -1, right? Or 0, nothing was found. Because I need to return the element. Or I can return an empty array too, right? If I have like an array a thing and I can return another array thing with the head element, I can have a situation like that to handle this case, because empty arrays are allowed. I can do that, but let's try to int first. So let's say that this save function is gonna receive an array and it's gonna pass that array to second element, but I need to test that return. So let's say we're gonna call second element of that array, passing that array off. So I can have some alternatives to that to this value. I can have something like let's see, I can have something like, hey, it's a number, it's a int value, it's a int value of something, right? And I must return that int value. Okay, and that is another possibility, is that I can't not find that element, and for that scenario I don't have actually a type for that, and that's a problem. How can I handle that? Let's say we just gonna try to do that and see what happens. Okay, we don't have an int constructor. This makes sense. Why we don't have an int constructor? Because int is not... What is int? Let's see here. So, yeah, I don't have a constructor actually, yeah. Int is just a type. It's not that don't have a constructor. It's not a kind, right? So actually the problem here is that this function here cannot pattern it like this, because int is not a constructor, right? Here I just need to do something like that. Yeah, so if I have a value, just return that. Okay, and let's see what happens. I'm gonna throw because partial, yeah. So how do I fix that? I will need to find how this is fixed, probably in the data array, because the data array, we have seen that data array has the head, which is not a partial function but a total function, which implements maybe type class. And maybe type class is a utility class that has nothing constructed, so we can like pattern image that, right, to nothing, or just so it's not a partial function, but it returns a type which must be handled by the function which is using head. So let's see inside of this function here. What's happening inside of that? So here we have the head function and the maybe type. Head is receiving XS value, it's array, right? And doing this operation here with 0. What is that? I'll try that. Yes, not something. Get the first element array or nothing is the array zip. This 0 thing here in this operator, I never had seen that. Let's see if there's such things here for that. As I see that index, right? So sentence hello world. So we have that syntax 0. We take just hello. Okay. If you have this operator with another number, we return nothing, like, because there is no such. Okay. So I must understand how index actually work. Yeah, indexed operation. This function provides a safe way to read a value at a particular index from an array. Okay. Index. It takes array and an index for that and returns a maybe. So we have this index and we have this index implementation with a foreign import passing those constructors just and nothing. So it's a native thing. Let's see. We're importing index implementation. The name is index implementation, right? I have not seen for import yet, but this is something I am curious how to handle a partial function, right? When you want actually to turn that into a safe function. Here it's not explained that. Let's see in the Jordan's reference about partial functions. Maybe there should be have something. Let's search here for partial function. Partial function with all not ours return a note to perform input. Next input X. Crash on invalid inputs via partial. Return an error containing type like maybe, either, fader, something. Okay. Use refined types via non-zero int or some other refined type. Return the output on valid inputs and the full value on invalid inputs. So how do I check invalid inputs? That's the thing. Let's see here. Via partial. So okay, yeah, partial. You divided by 0. Int string on safety vision. So here's an example of how to okay, this is an example of how to implement that part of function, just that. New import use when a function return a value. Let's see the via maybe here. That's the thing that I was looking for. So we have to import maybe, of course, a type that indicates an instance of A might exist. A type that indicates an instance of A. I don't know still what is that. A box with nothing in it, empty box, a box with just an instance of A in it. Okay. Maybe it's often used in situations where a function might return null. We don't need to do anything with the error itself. Using our example of division, expression 5 divided by 1, explanation value 0 returns 5, fp returns just 5. Okay, so this is the runtime thing, right? And the compile time thing. Expression x by 0, it's a invalid value. So at runtime it returns null. Okay. And the compile type returns nothing. The following function safety vis demonstrate this. Let's see here. No matter what arguments you pass into it, you always get a value out. Maybe int, and here we have a 0 pattern mating, right? In this case, we just okay. So that's what happened. So if I have a scenario where I need to, handle a situation of like that, I can just return maybe for that. And maybe for internally, probably by decompiling, right? It's gonna return null for that nothing when it happens, I guess. Okay, so it's enough to understand that. And finally we have superclasses. Let's see here. Just as we can express a relationship between type class instance by making an instance depend on another instance, we can express relationship between type class themselves with so-called superclasses. We say that one of type class is a superclass of another if every instance of the second class is required to be an instance of the first, as we indicate the superclass relationship in the class definition by using backward facing WR. I have seen that. It's like the same group and monoid, right? Monoid same group is a superclass of monoid. So monoid concerned about having all the instance of same groups, all the members of same group instanced. In general, it makes sense to define superclass relationships when it allows for the subclass mention the members of the superclass. Is there reasonable to assume? Yes. For nth pairs of odd and equal instances, if the two values are equal, that the equal instance and the compare function should return equal. In other words, A equal to B should be true exactly when compare A to B plus 2 equal. This relationship on level of law justifies the superclass relationship between equal and odd. Another reason to define superclass relationship is in the case where there is a clear is-a relationship between the two classes. That's every member of superclass is a member of superclass as well. And finally we have the exercise here. And I'll finish for today, right? But I'll keep that exercise for our next live stream. Right? Probably not tomorrow because tomorrow I'm a little busy. I'll be back probably Thursday. Probably Thursday, right? For a small session where we can like solve those exercises here. It's in my reading. I put that here. Close that one. Keep that, right? And let's see if I don't commit anything. Today was just reading, so it's okay. If you want to follow the exercise I'm doing, I have did that for another exercise. The source code is right here. I'm solving that, right? And we have did the exercise before that, and that's probably the last block. Let's see here. Yeah, it's almost finished it. So if you want to follow, please follow the channel to receive the notification. And it's that. See you again. Bye bye.